Alrighty, we're going to do a little video about some exponent rules. So this is something that you probably learned back in Algebra 1, but it has been a hot minute since you have done it. So that's why we are reviewing that. It's also something good just to go back and touch on before the year's over. So here we go. The first one here, we've got 3x times 4x to the third. So what we want to do is multiply our coefficients together and get 12. And if you have x, remember that's x to the first times x to the third. What do we do with these exponents? Do we add or multiply? Actually, just going to add, because if you think about having 1 here and 3 more there, that'd be 4 altogether, right? So 12x to the fourth is that one. All right, let's move on to number 2 here. See an interesting looking exponent for 3 when the y here. We'll see what's going to happen. All right, so 3, there is no other coefficient, so we'll just have 3 other than 1, but really didn't count. What is anything to the 0 power? Anything to the 0 power is like a 1. It is a 1. So it is really like we're looking at 3 times 1 here for that first term. So that y, really don't need it anymore. And this is just 1y, so y for that one. We have no more x's, so x to the third. So the only thing that dissolves into a 1 is the thing with the exponent of 0 on it. And the only thing that had that was the y, not the 3. There's a difference between 3y to the 0 and then 3y, the whole thing to the 0. So this would be like 3 times 1, but this would be the entire thing would just be 1 because 3 is also getting that exponent of 0. All right, so let's keep going. Here we have another 4 and a 3, so I'll multiply those and get 12. All right, now I see y, no more y's, and no more x's. Okay, but look at the directions. It says your answer should only contain positive exponents. So how are we going to make this y to the third and x squared not be a negative anymore? Well, one thing we talked about was in our notes, you can put those variables or those terms, whatever it is, on the other side of the fraction. If it's on the top, move it to the bottom. If it's on the bottom, move it to the top. And then it will change the sign. So 12 does not have a negative exponent. It's just 12. But y to the third is negative. So if we bump it down here to the denominator and also scoot x down, then we have positive exponents. So that's how you get those to be positive. You put them on the other side of the fraction, meaning if it's on the numerator, move to denominator, vice versa. All right, number 4. This is a different problem. We got an exponent out here to the outside. Okay, so this is a power raised to a power. What this is going to do, it's going to apply this power to every single term inside these parentheses. So what is your exponent on your 4? Well, right now it's just a 1. So let's multiply these exponents. Let's distribute that power through. So that would be 4 to the negative 2, x to the negative 8, and then y to the positive 2. All right, let's rewrite this to where we've got some positive exponents. So that would mean that y squared stays on the top. But these first 2 terms are negative exponents. They're going to scoot down here to the bottom. Now, I think there's a better way to write this, and that would be to go ahead and square your 4. So it'd be a 16 on the bottom, x to the 8th. And that is all you can do with that one. So I recommend on this one I say distribute the exponent through, and it really is just raising everything in here to that power and then adjusting your answer as you get done with that. I think that's the easiest way to do those. All right, so let's just go ahead and perform the operation here on this one and then see what we need to fix. So first thing I see is this 4 that's been applied to everything in these parentheses. So let's do what we did on the other one. Let's apply that 4 to all these powers. So that would be 2 to the 4th, x to the 16th, y to the negative 12th. All right, let's see if we can rewrite that just a little bit. 2 to the 4th is 2 times itself 4 times. That is 16, x to the 16th, y to the negative 12th. All right, now bring down this other thing we're multiplying it by, times 2x squared, y to the negative 1. Now, I know we've got some negative exponents, but let's just hold off and see what happens when we combine everything. Then we'll fix it at the end, all right? So coefficients, multiply those, you get 32. All right, gather up your x's. It's x to the 16th times x squared. So what do we do with these exponents? We add or multiply? We got to add. So this is similar to the very first question we get here. So that's x to the 18th. And then what do we do with our y's? We've got negative 12 and negative 1. So we add those and get negative 13. We're almost there. All right, this is getting pretty long here. 32 x to the 18th. We need to scoot this y to the 13th to the denominator because, remember, it's assumed to be on top of the fraction unless you see a fraction bar. So if it's not, you got to scoot it down to the bottom. Because here it's assumed to be on the numerator, but we want it positive, so we scoot it down to the denominator. All right. Okie dokie. We got 2 more. All right. So number 6 here, a little bit simpler, I think. We've got a division symbol here, the big fraction bar. So there are no parentheses or anything like that. So I think we're good to go. So let's just divide these things to start with your coefficients. So you would get 2. Now let's just go ahead and draw a fraction bar because we really don't know what's going to happen. All right, so what did we say to do when you're dealing with exponents and they are in division? We said to subtract the exponents. There's a couple ways you could think about this, but if you just use the rules, you would say 4 minus negative 4. What would that leave you with? That'd leave you with 8, right? Another way you can think about it is, hey, this x to the 4th, if I scoot it up here and make it x to the 4th on top, that would give us 8 x's, no matter which way we look at it. All right, so there's that one. Then you've got y to the 4th, y squared. So if we subtract those exponents, that would be y squared. And you can, again, think about 4 of these, 2 of those, all 2 of these are going to cancel with 2 of those, leaving you with 2. But when you've got negative exponents, you kind of have to use a different way of thinking. And we actually didn't even need the bottom of that fraction. Everything ended up being positive when we subtracted or did our rules, so everything is on the top. All right, last one. This is a quotient. That's what you call a division problem, the answer to it. And we have an exponent on the outside. So guess what happens? This 4 gets applied to everything on the numerator. Let's do that first. 2 to the 4th, h to the 8th. You multiply, yes. K to the 8th. And it gets distributed or applied to the denominator. Everything. So all these things. So that would be 2 to the 4th. Again, now there is no exponent there, so we assume that to be 1. So that'd be a 4 multiplied. J to the 4. And then K to the 12th. All right, now before you get too excited, 2 to the 4th and 2 to the 4th, aren't those the same thing? So those will just cancel each other out. So we're just dealing with an answer that has variables in it. All right, I see h to the 8th and h to the 4th here. So if we use our subtraction rules, we would be left with h to the 4th. All right, let's see. There are no more j's, so j to the 4th is going to hang out on the denominator. And then lastly, k, you've got k to the 8th and k to the 12th. All right, so if you're trying to reduce these and you do 8 minus 12, what does that give you? That gives you a k to the negative 4, right? If you use the rules, it's automatically assumed that that answer is on the top of the fraction, but I think we kind of are already used to this from another unit, so we would know to leave that k down there on the denominator because it's bottom heavy, so to speak.